So this might be a quick lesson, but patterns and arithmetic sequences. I'm breaking it up because we only got 45 minutes in here today. The goal, you'll be able to use the formula to find different parts of an arithmetic sequence. Okay? And so what parts are there in the arithmetic sequence? Well, there's 1, 2, 3, there are four different things you can find just based off of the arithmetic sequence formula in general. Okay? First off, before we get started, we're going to talk about patterns, just to make sure that everybody has the ability to see patterns. Because that's the main thing. If you cannot figure out what the pattern is, then we're definitely going to have an issue in this particular little unit. Now, a number sequence is a pattern of numbers arranged in a particular order according to a specific rule. All right? And these 4 examples that I have here, these are just to see and just to check to make sure that we are capable of finding the patterns in these sequences. So, let me read through the first one, and if you think you know what the pattern is, please raise your hand. You have 8, 11, 14, and 17. Raise your hand when you have the pattern. Okay. Huh?
Add 6 minus 3.
All right. So, Matthew?
Add 6 minus 3.
Too much. More simple. What is it?
Plus 3.
Plus 3. You're adding 3 to the previous term to get the next term. What about the next one? We have 800, 400, 200, 100.
You're dividing by 2.
You're dividing by 2, or what's another way to say that?
Multiply by 1/2.
Multiply by 1/2. Either one would be acceptable. That is the pattern. For the previous term, yes?
Yeah.
And did everybody know what I mean when I say previous term?
Last number, right?
The last number. Okay. An individual number of an element of a sequence is called a term. So when I refer to term, I'm talking about a number within the sequence, okay? Let's look at the next one. 1, 4, 9, 16, 25. Raise your hand when you see the pattern.
Oh, I don't got that.
Yeah, right? Not n, but
I thought it was,
add 3 plus however number of numbers. 2 times however many numbers.
3 plus
I thought it was 1 squared,
3
2
plus
squared,
n.
3 squared.
3 plus
Okay, yeah.
3 plus n, right?
2.
Ooh, that sounds very difficult.
I don't know.
3 plus 2n. Let's see. Now what is n? I hear this
Number,
n.
not
What
a
is
number.
n?
It's first number.
N is the first number?
No, n
N is
not a
is
number.
n is the
Yeah.
number of the number.
That's
The
So-
placement of the number.
So the placement, the
Yes.
term placement. So this would be. So this would be the first term,
Yes.
second term, third term. Okay, so that's what you're saying. All right, interesting. I probably would have been a little more simple, such as n squared, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. So n would represent the place within the sequence, and then you just square the number. I mean, I'm pretty sure that 3n plus 2 is 3 work too. Well, what about the next one? We got 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. Here I come. Where's that from? You ready?
Schoolhouse Rock.
Yes, Schoolhouse Rock. What's the pattern?
Who plays in the movie?
I don't know. It's a cartoon.
It's a cartoon.
Oh, never mind. I do
Okay,
about
you know nothing about
a movie.
What's the pattern?
Yeah.
Plus 5. Okay, so are we good with finding the patterns? Trip you up on that third one, huh?
Theoretically.
Plus 5.
But just,
Theoretically not.
just want to make sure everyone can find the pattern. An arithmetic sequence, okay, is terms that increase or decrease by a constant value called the common difference, which is represented by the variable d. That formula that you see in the middle of the screen, u sub n equals u1 plus n minus 1 times d, is the formula. To find any number in the arithmetic sequence, it could also be used to find the first term, the number of terms, or even the common difference. And then you have the little legend at the bottom so you know what each symbol stands for. So we're going to look at some examples. We'll start simple, work our way to more complex. Not too many examples with arithmetic, okay? I'm going to try to hit every possible scenario that you can run across with this, okay? So the first example says find the 12th term of the arithmetic sequence. And then we're going to find an expression for the nth term. And this is also one that could be very well be in a non-calculated section. So you're not going to sit there and you're not going to add or subtract the same number until you reach the 12th term, because heaven forbid they decide to give, say, the 27th term or the 51st term or the 102nd term. Then you'd be wasting a lot of time if you haven't realized time of the essence of these IB exams. So first, that formula is definitely going to come in handy. And what would the 12 represent in this formula?
The N.
The n, because we're looking for the 12th term. So this would be u sub 12. U1 represents our first term, which is,
13.
and d represents our common difference, which is
Positive 6.
positive 6. So 12 minus 1 is,
11.
I was going to say 12 minus 11. 12 minus 1 is 11. We're going to times that by 6 to get, and that is, our 12th term. And that's how you want to write it, because heaven forbid this is like an A through F, and you want to make sure the grader knows that, hey, A sub 12 is my 12th term, is right here. Grader, look here.
Step 1, step
Now it says find the expression for the nth term. What does expression mean? What does expression mean? An equation to represent the nth term, okay? So if I'm looking for an expression to represent the nth term, what variable am I not going to plug in anything for?
3. N.
N. So if I look at the general equation, that means u sub n will stay that. I'm going to plug in my first term, which is, I'm going to leave n alone because I'm looking for the nth term, and I'm going to plug in what for d?
Positive.
Positive 6. So I have u sub n equals 13 plus, what do you think I want to do?
Distribute.
Distribute. So I have 6n minus 6. Am I done?
No.
What do I have to do?
Simplify.
Simplify. So my answer is going to be 6n plus 7. And that is the expression for the nth term. And so at this point in time, I could find the 100th term. So all I have to do is plug in 100 for n, multiply by 6, add 7. And again, the grade one could be a non-calculated problem. Simple enough, simple numbers. Questions? Here's the next one. Find the number of terms in the arithmetic sequence. 84, 81, 78, ... 12. Those 3 dots, ellipses. That means there's some other numbers in between 78 and 12 following the particular pattern.
So would 12 be the last one?
Yes, 12 would be that last term, that nth term that we're looking for. Okay? And so since 12 is that last term, and we're looking for the number of terms, you can kind of set this up using that same general formula. What's D? What's the common difference? Negative 3. I'm subtracting 3 from every term. What's my first term? 84. The one thing I don't know is the n. So I don't know what term 12 is, but I do know that whatever term it is, whatever n is, 12 is that nth term. So I plug in 12 for u sub n, and there's nothing but an equation to solve. Now the one thing that you can always double check, whenever you're looking for your number of terms, it should be positive and a whole number. Because you can't have a 5.5 term or anything like that. So it needs to be a whole number. So that's one way you can always check to make sure you do your algebra right. Okay? So let's go ahead and solve. How would you solve this problem? Just curious.
Make sure you turn the recorder.
Divide by 3.
Hold
We're good. All right? Go ahead. How would you do this? Tell me what you said.
I said distribute the 3.
Distribute the negative 3?
Yeah.
How'd you say?
Divide by, wait, you can't divide by 3.
Any other suggestions? Okay, so you do that one. Okay. So we're going to distribute negative 3. So it's going to be a,
Negative 3a.
Plus 3.
be very careful, make sure you don't forget your old school rules of distribution. Then what?
Then add the 84 and
to get,
Negative 3 plus 87.
and then,
Subtract 87 from 12.
so I have a negative 3 on one side and negative 75.
And then divide by negative 3.
And so in, two negatives make a, so that's one thing checked off, and you're not gonna sit there and actually keep subtracting 3 until you get to 12, because on top of that one, you gotta keep track of what term you're on, and heaven forbid you lose track and you gotta start over, you're done wasted too many minutes.
22 on paper.
I mean, that would work.
It's still gonna take a,
I
it'll
don't
take a minute.
I don't.
Okay, so in this last example, it says an arithmetic sequence, u sub 9 equals 48 and u sub 12 equals 75. Find the first term and the common difference, okay? Now, that's true. Okay, the way you look at it, all right? Basically, you have your 9th term and your 12th term, okay? And we're trying to figure out our first term and our common difference. The easiest thing to find first is your common difference, okay? And the way you do that is you take your 12th term, subtract it from your 9th term. Or your 13th term, subtract it from your 7th term, whatever. Take two terms and subtract it from each other. And then you divide it by how far apart they are. Or you can just say, well, 75 is my 12th term, and 48 is my 9th term, which is a difference of 3. I don't know, for some reason, sometimes people count, they would say, well, is this 4? Do I count the 9th term?
9, 10, 11, 12.
So an easy way is basically subtract the terms, subtract where they're placed, and divide them. So what's 75 minus 48? And 12 divided by 12 minus 9? And what's 27 divided by 3? And that is the common difference. You would still get the same thing if you did a system. If you push the numbers back, there's so many different ways you can do this. But I like this one because, okay? And then now that you have your common difference, you can sit there from the 9th term and continue to subtract 9 until you reach the first term, or
Yeah.
use the formula.
They can use the formula wrong, so not.
Okay? And by using the formula, you would pick either of these terms. Which one do you want to use, the 9th or the 12th?
12 school.
And so I'm going to plug in 9 for n. I'm going to plug in 9 for d, because that's what we came up with. I'm looking for my first term, so u sub 1 stays where it is. And then for the 9th term, I'm going to plug in 48. It worked the same way you use 75 and 12. What's 9 minus 1?
8.
Times 9 is?
72.
So then I would just subtract to find my first term is?
Negative 24.
I did.
Never be my calculator. So then my first term would be negative 24. We could have used this number 75 and 12. We would just have to plug in 12 for it instead. So no matter which one we use, like if I use the other one, 75 equals u1 plus 12 minus 1 times 9. I have 75 equals u1 plus 99, because 11 times 9. And then when I subtract 99 from both sides, I'll still get